I'm going to take you through a masterclass in National 5 Pythagoras. So Pythagoras' theorem is actually a National 4 skill. I'm going to do a quick recap of what Pythagoras found, and then we're going into the converse of Pythagoras, and then finally three-dimensional Pythagoras. Okay, and hopefully by the end of this video you'll be able to support your child through all of National 5 Pythagoras. Right, so let's take a look at the recap. Pythagoras, he was a strange man but an excellent man that found a connection between all three sides of a right angled triangle. So he said that the sum of the square of two sides will equal the square of the hypotenuse, and it looks like this. Okay, they use areas to prove it. You don't need to know that. Okay, and then they'll use the formula a squared plus b squared is equal to c squared. It can also be written, as I'm sure you know, as c squared is equal to a squared plus b squared, and that is my preferred way of writing it as well. Okay, so a quick recap of what it is, okay, and how you solve Pythagoras' theorem. So you start with the formula, doesn't matter which way you write it. You substitute in the values that you've got, bearing in mind that the side across from the right angle is your hypotenuse. And whenever you're trying to find the hypotenuse, it has to be a plus in the formula. That'll change if you're finding a shorter side, and I'll take you through that in a minute. So we substitute in the values in here. Okay, then we calculate the squared. So 5 squared, 5 times 5, 12 squared, 12 times 12, to get 25 and 144. We then add them together. Okay, as you can see, we've still got a squared term. We want, okay, just the c on its own. They've swapped sides there. I would have done that at the beginning, but it doesn't matter. Okay, so to get rid of that squared term, you would take the square root of both sides. Okay, by doing that, you end up with something that looks like that, and that square root cancels with the square because they're exact opposites of each other. Okay, so we're left with c is equal to the square root of 169, which is 13 centimetres or 13. Okay, please try not to forget your units. Right, so finding the shorter side, we'll take c squared equals a squared plus b squared. Now that connection that Pythagoras found must be, we must be able to use it to find any side of the right angle triangle if there's a connection between all three. So what we do is we rearrange the formula. So a squared is equal to c squared minus b squared. Okay, now let me give you a quick diagram, because as I've said, the one directly opposite the hypotenuse will be c. A and B will be the other two sides, and it doesn't matter which way around they go, okay, because you can also get b squared is equal to c squared minus a squared. But the key to finding the shorter side is make sure you put the hypotenuse first, because that's the longest side, and ultimately you're going to take the square root, and if you take something away from, if you take the shorter side minus the longer side, you're going to get a negative, and we don't want anybody square rooting a negative just now. That is advanced higher, and it goes into complex numbers. Okay. So finding the shorter side, so there's my triangle. I'm going to use the formula a squared equals c squared minus b squared. At this stage I'm doing the same thing that I did last time. I'm substituting in all the values that I've got, with the hypotenuse coming first. So 15 squared is 225. I should probably have put that in there. So x squared is equal to, square them out, 225 minus the 49, which will give you that 176. Then take the square root of them, and you'll get 13.3. Now one way to check is to make sure that that side is shorter than your hypotenuse, and as we said, the hypotenuse is the longest side, and it's opposite, directly opposite the right angle. Okay, so let's go into a wee bit of converse of Pythagoras, and what we say is that if this works for Pythagoras' theorem does only work for right angled triangles, then what we must be able to do is we must be able to flip it on its head and say that we can then prove that a triangle is right angled if Pythagoras' theorem works. If Pythagoras' theorem doesn't work, then it isn't a right angled triangle, and that's the converse of Pythagoras. Okay, so a non-right angle triangle, c squared does not equal a squared plus b squared, and that's what we're proving. Okay, so if we take a triangle here, okay, that's 8 squared, the hypotenuse is 8, and the other two sides are 5 and 2, then what you end up with is 64 is equal to 25 plus 4. And as you can tell, 64 definitely does not equal 29, so we've proved that that cannot possibly be a right angle triangle because Pythagoras' theorem doesn't work. But they have to have that statement at the end where they would say that since 8 squared does not equal 5 squared plus 2 squared through the converse of Pythagoras, this is not a right angled triangle. Okay, so let's take a look at an example and how we would then prove it. Okay, so we've got this triangle. This is what we call a Pythagorean triple, and it will work with every triangle, and it'll work with every multiple of each side. Okay, so what we end up with is c squared is equal to a squared plus b squared, and we'll start with Pythagoras' theorem. We're going to start thinking that it is going to work. Okay, we'll substitute in our values. 5 squared is equal to 4 squared plus 3 squared. So 25 is equal to 16 plus 9. So 25 is equal to 25. Wonderful. So what we've proven is that this is definitely a right angled triangle. But as I've said, we have to do Pythagoras' theorem and then make a statement at the end. And this is what the statement will look like. Okay, since 3 squared plus 4 squared equals 5 squared, by the converse of Pythagoras' theorem, the triangle is right angled at B. And it has to be at B because that's the one directly across from the hypotenuse. And they have to have that statement in to get the final mark and prove that the triangle is right angled. Okay, so let's take a look at one that doesn't work. Okay, so what we're going to do, we're going to start again. C squared is equal to a squared plus b squared. We'll substitute in what we think is our hypotenuse, and we would think that this one is our hypotenuse because it's the biggest side. Let me rub that out though, because that isn't true. Okay, so substitute them in. 11.5 squared equals 9.7 squared plus 5.9 squared. You then chuck that straight into your calculator. So you'll get 11.5 times 11.5 is 132.25. 9.7 squared is 94.09 plus your 5.9 squared is 34.81. Add the two together. I want to find the sum of them. And I get 128.9. Now that clearly is not equal to 132.25. Okay, so then I have to say that at the end. I'm just going to rub that out because the statement's just about to come up. Okay, so they need both, and then you need to say that since 5.9 squared plus 9.7 squared does not equal 11.5 squared, by the converse of Pythagoras' theorem, this triangle is not right angled at A. And they can then apply these questions to rectangles, because obviously the corners have to be 90 degrees, so they can check the diagonal of the right angle. They then prove that it's not a rectangle, because obviously if it's not 90 degrees in the corner, it's not going to be a rectangle, and they can take it that way as well. Okay, so let's have a look at three-dimensional Pythagoras. Now you've got two types of diagonals in Pythagoras' theorem. So a three-dimensional problems will include calculating the length of a right-angled triangle, but they tend to be in cubes, cuboids, etc., because we want the space diagonal and we want the face diagonal as well. So let's go through what that is. So as you can see, the rectangle at the bottom, now the rectangle I'm talking about is ADCB. Okay, that AC is a face diagonal, it's on the face of the rectangle, okay, whereas AF, that line there, is a space diagonal. Okay, so space diagonal cuts all the way through the cuboid, face diagonal is on the face of the rectangle. Okay, right, so let's take a look at this one. Calculate the length of the face diagonal, EG, of this cuboid. So what I want, I'm going to draw out the right angle here, is I want that, okay. So if I draw out that right angle triangle, what I'm telling you is that this side is 12, this side is 5. I've got EG, there's my face diagonal, okay, and I've got F in the bottom. And what I want to do is I want to find the length of the face diagonal EG, and I'm going to call that X. Okay, as you can see, I'm finding my hypotenuse, so I'm going to use C squared is equal to A squared plus B squared. I'm then going to substitute in my values. X squared is equal to 12 squared plus 5 squared. X squared is equal to, square them out, 144 plus 25. X squared is equal to 169, add the two of them together, take the square root of both sides, and you're getting X is equal to 13 centimetres. Okay, so we've just found the face diagonal, EG, and now as you can see for part B, and sorry I'm going to have to rub this out, what I want to find is I want to find the space diagonal. Okay, and the space diagonal I'm talking about is this one here, okay, which is going to come down there and use that face diagonal there, and if you remember where you found that was 13 centimetres. Okay, so let me draw out that right angle triangle. I prefer to draw it out. Now that length of the cuboid, XG, is 3 centimetres. Okay, the face diagonal that we've just found is 13 centimetres. Okay, and I'm going to find this side, which is EX. I could use the letters of the line if I wanted to, but I'm just going to call it Y. Okay, so again, I'm looking for my hypotenuse, so it's c squared equals a squared plus b squared. Substitute in your values, y squared is equal to 13 squared plus 3 squared. Square them out, 13 times 13 is 169, 3 squared is 9. So you would then have, add the two of them together, y squared is equal to 178. Get rid of the squared, so y is equal to, take the square root of both sides, 178, square root of 178, sorry. So y is equal to 13.3 centimetres. Okay? Right, now for three-dimensional Pythagoras, they tend to like to put both of them in one. Okay, so what I would like to find just now is I would like to find the space diagonal CE, which is that one there. Okay, but as you can tell, I don't have all the information. All I've got is I've got that 8 centimetres EA. Okay, so what I then have to do is I need to say, right, well, I want to find AC if I want to find this space diagonal. And again, I'm going to call that one Y because I'm going to call this one X. Okay, but you'll notice that what I've got at the bottom is I've got a face diagonal. Okay, so AC, I'm going to draw that out just now. There's X, 7 and 5. Okay, so again, I'm finding the hypotenuse. Not always the case, but seems to be the case just now. So I'm going to substitute these into c squared equals a squared plus b squared. Okay, so I've got 7 squared plus 5 squared. Square them out. C squared is equal to, sorry, I should change that, x squared I've called it. That doesn't make any difference, but I have, so I'll change it. 49 plus 25. So I'll get x squared is equal to 74. Take the square root of both sides. And then x is equal to 8.6. And that's in centimetres. Okay, so I've found the face diagonal, and now I've got enough information that I can find the space diagonal. Okay, so get rid of all this, give myself some space. And what I want to find is I want to find Y. Apologies for my diagrams. That one's 8. Okay, that's A, E, C. Okay, so again, I'm finding the hypotenuse. So I've got c squared is equal to a squared plus b squared. I've called it y, so substitute in my values. Y squared is equal to 8.6 squared plus 8 squared. Okay, so 8.6 squared is 73.96. 8 squared is 64. Add the two of them together, I'm getting 137.96. Take the square root of both sides. So y is equal to 11.7 centimetres. Okay, and I'm just going to state that at the end because it asks for the space diagonal CE. CE is equal to 11.7 centimetres, and we can back that up. Okay, so as you can see, I've taken you through a recap of Pythagoras' theorem, which is a national 4 skill. Okay, but obviously we need it to be able to find the converse of Pythagoras and then into three-dimensional Pythagoras. I hope you found that useful.